Hello, today I'm going to talk about plate tectonics. So plate tectonics by definition is the movement of plates of the Earth's crust. So the Earth has layers, which you may or may not recall from middle school. So the upper level is crust, and that's going to be our solid Earth. That's made up of plates that float and move along a liquid mantle. The movement of our plates creates various landforms and seafloor features. So when it comes to our complete theory of continental drift or plate tectonics, so we've got our Earth's crust is divided into plates that are moving. Our continents were once a single landmass called Pangea, in which plants and animals moved about, all of them. And they have over time have broken apart, moved around, created various landforms such as mountain ranges, like the Himalayas and the Andes Mountains of South America, as well as seafloor features. So things like trenches, mid-ocean ridges, and some of our volcanic islands are going to be a result of plate tectonics. So this idea of plate tectonics, it wasn't a theory when first proposed, but this idea was first developed by an Alfred Wegener. He published a paper in 1912 which focused on the formation of the continents. Then he expanded it to a book in 1915 that focused on both the continents as well as the formation of the oceans. However, this idea was not really accepted and not considered a scientific theory until the late 1960s. Additional data that didn't exist when Wegener was alive was needed. We needed increased technology in order to see the ocean floor and to travel down there. In the 1960s, we had the discovery of hydrothermal vents, which are one of the features that develop when the Earth is expanding at the mid-ocean ridges, or not the Earth, but when our plates are moving and the ocean is expanding. And so we needed that technology. Hydrothermal vents were discovered by a submersible called Alvin. And if you recall from the first week of school, and I know that's been a while, first week of school, one of your assignments was to watch a TED Talk by Dr. Robert Ballard. He is a physical oceanographer. And so he went down, he was one of the people on board the Alvin when it traveled to the bottom of the Atlantic Ocean, or it wasn't the Atlantic, that was in the Pacific, where he discovered some hydrothermal vents. There's also, in addition to our big mid-ocean ridge splitting the Atlantic, there are some in the Pacific as well, and this is where the hydrothermal vent discovery was first made. So we needed that geological oceanography and the knowledge from that to apply to all geology in this theory. Here is a link to a YouTube video that goes into much more detail about the development of this theory. I encourage you to watch that when you're done watching our notes. So in plate tectonics, there are three types of boundaries. We're going to have where our two plates are moving apart, where two plates are sliding next to each other, and where two plates are colliding. So a convergent boundary is where they're colliding. And in the case of the oceans and oceanic crust, continental crust is less dense. So the oceanic crust is going to be subducted. It's going to go down. As it goes down, we get an ocean trench formed, and then it melts. And when it melts, that extra magma creates pressure for volcanoes. And so we get two features here, ocean trenches and then volcanic islands. So looking here at my lovely map again. So some of the islands formed by this process. So Japan, very large, but volcanic islands formed by the Pacific plate subducting under the Eurasian plate. In Alaska, there's a chain of islands called an island arc. These are the Aleutian Islands, and they're formed by the Pacific plate going under the North American plate. And convergent boundaries are referred to active boundaries because we do tend to have lots of volcanoes and they appear very active. Divergent boundaries are passive. It's where they're moving apart. And there does tend to be, the volcanoes here are less exciting. They're not as explosive, but it's really more the magma slowly seeping upward as the plates move apart. So we're getting new ocean crust made here. So in the Atlantic Ocean is where we have our largest continuous mid-ocean ridge. This is happening between the North and South American plates are moving and the African and Eurasian plates are moving apart from each other. Now we do have one point where this mountain range has broken the surface to form an island, and that's the country of Iceland. Iceland sits on the middle and it's formed by the mid-ocean ridge. There are places in Iceland where you can go and visit and stand on the crevice of the oceanic plate and look down into the magma below. One of my bucket list items. And then last boundary type are the transform boundaries. These are when two plates are sliding past each other. So they're not running into each other, they're not moving away, they're just sliding next to each other. Earthquakes are very common here. Think California. California sits on a transform boundary. Southern California is actually on part of the Pacific plate. Rest of California is on the North American plate. And the Pacific plate is slowly moving up past the North American plate. Give it a few million years, and eventually Southern California will be in what we now think of as the North Pacific Ocean. That'll take a while. There's also one more YouTube link down here going into more of some of the process of how these things move about.